Hi everyone, in today's video you will learn how to display the digit count values on 7-segment display using decoder or driver ICs. This video is split into two parts. Part 1 is single digit count values on 7-segment display and part 2 is 2-digit count values on 7-segment display.
At the end of this video, you will be able to construct and test a decade counter using IC74LS90 with a BCD binary coded decimal to 7-segment decoder, driver and 7-segment display. Construct a 2-digit counter and display the count value. Let us collect all the tools, equipment and materials required to do this practical. Digital trainer kit with user manual, IC74LS90 with datasheet, IC74LS47 with datasheet, 7-segment LED display with datasheet, male-to-male jumper wires, magnifying lens. Let us discuss about IC74LS90 and IC74LS47. IC7490 is a 14-pin dual inline package that can count binary numbers from 0000 to 1001. IC74LS90 is a 4-bit binary counter with a decade counter configuration. It counts in decimal, which means it goes through the numbers 0 to 9 in binary 0000 to 1001. Pin details of IC74LS90. Pin 1 clock input B, Pin 2 reset input 1, Pin 3 reset input 2, Pin 4 no connection, Pin 5 power supply plus 5 volt VCC, Pin 6 reset input 3, Pin 7 reset input 4, Pin 8 output QC, Pin 9 output QB, Pin 10 ground, Pin 11 output QD, Pin 12 output QA, Pin 13 no connection, Pin 14 clock input A. IC74LS47 is a 16-pin dual inline package. It is a BCD to 7-segment decoder driver IC commonly used in digital display applications. It is designed to convert a 4-bit binary coded decimal BCD input into the necessary control signals to drive a 7-segment display. Pin details of IC74LS47. Pin 1 BCD input B, Pin 2 BCD input C, Pin 3 active low display test input, Pin 4 active low blank output, Pin 5 active low ripple blanking input, Pin 6 BCD input D, Pin 7 BCD input A, Pin 8 ground, Pin 9 7-segment output E, Pin 10 7-segment output D, Pin 11 7-segment output C, Pin 12 7-segment output B, Pin 13 7-segment output A, Pin 14 7-segment output G, Pin 15 7-segment output F, Pin 16 power supply plus 5 volt VCC. Let us discuss about the 7-segment LED display. A 7-segment display is a type of electronic display device that can represent decimal numbers using 7 individually illuminated segments. Each segment is a small light-emitting diode or a similar technology. The arrangement of these segments allows for the representation of numerical digits from 0 to 9 and sometimes additional characters such as letters A to F for the hexadecimal displays. The decimal point segment is an additional segment on the display that is often used to represent decimal fractions or other symbols depending on the application. Let us discuss how to connect the IC74LS90 and IC74LS47 with 7-segment LED display. Check both the IC's part number using magnifying lens. Ensure that the pins of the devices are not bent or damaged. Identify pin 1 of both the ICs. It may have a small notch or dot to indicate pin 1 and align them correctly in the right position over the breadboard in the digital trainer kit. Gently insert both the ICs side by side along with the 7-segment display such that the dot pin is placed at right hand bottom corner. Start with the IC74LS90. Connect the pin 5 of IC74LS90 to plus 5 volt power supply VCC and pin 10 to the ground in the digital trainer kit. Next, connect the pin number 16 of IC74LS47 to plus 5 volt power supply VCC and pin number 8 to the ground. Connect the plus 5 volt to common terminal of 7-segment LED. Connect the pin number 11 of IC74LS90 to pin 6 of IC74LS47. Connect the pin number 12 of IC74LS90 to pin number 7 of IC74LS47. Connect the pin number 9 of IC74LS90 to pin number 1 of IC74LS47. Connect the pin number 8 of IC74LS90 to pin number 2 of IC74LS47 as per the circuit diagram. Connect pin 14 of IC74LS90 to the clock input. Connect pins 1 and 12 in IC74LS90. Connect pins 2 and 3 in IC74LS90 and connect it to input toggle switch S1 as shown in the circuit diagram. Connect pins 6 and 7 in IC74LS90 and connect it to ground point. Connect pin 13 of IC74LS47 to pin 7 of 7-segment LED for a A terminal through 100 ohm resistor. Connect pin 12 of IC74LS47 to pin 6 of 7-segment LED for B terminal through resistor. Connect pin 11 of IC74LS47 to pin 4 of 7-segment LED for C terminal through resistor. Connect pin 10 of IC74LS47 to pin 2 of 7-segment LED for D terminal through resistor. Connect pin 9 of IC74LS47 to pin 1 of 7-segment LED for E terminal through resistor. Connect pin 14 of IC74LS47 to pin 10 of 7-segment LED for G terminal through resistor. Connect pin 15 of IC74LS47 to pin 9 of 7-segment LED for F terminal through resistor. Connect pins 3, 4, 5 in IC74LS47 to plus 5 volt power supply. Switch on the plus 5 volt DC power supply. Apply logic 1 to the pin number 2 and 3 momentarily to reset the counter and observe the LED display. Apply clock pulse. Note down the segments of display and record your observations from 0 to 9. Clock pulse reset 7-segment display 0, clock pulse 1 7-segment display 1, clock pulse 2 7-segment display 2, clock pulse 3 7-segment display 3, clock pulse 4 7-segment display 4, clock pulse 5 7-segment display 5, clock pulse 6 7-segment display 6, clock pulse 7 7-segment display 7, clock pulse 8 7-segment display 8, clock pulse 9 7-segment display 9 and so on.
Thus, we have constructed and tested the single-digit count values using make connections between IC7490 and IC7447 with a 7-segment LED display as per the given circuit diagram.
Thank you.